May 10th, 1942. The machine gun plant on the third floor of Yokosuka Naval Arsenal, Tokyo Bay. Commander Takeo Yamamoto stood before a workbench covered in disassembled rifle components, his hands resting on the smooth walnut stock of a weapon that would reshape everything his engineers thought they knew about infantry firearms. The rifle before him bore the markings of Springfield Armory, batch number 400,000 series, manufactured in early 1942. It had travelled 3,000 miles from the captured warehouses of Manila to this converted workshop, alongside 9 identical examples. Around him, a dozen naval engineers crowded closer, their notebooks ready, their skepticism barely concealed. These were men who had spent careers perfecting the Arisaka bolt-action design, men who understood the elegant simplicity of manual operation, men who believed semi-automatic rifles were theoretical luxuries unsuitable for mass production. They had studied Czech designs. They had tested American Pedersen rifles. They had concluded, repeatedly, that such weapons were too complex, too expensive, too unreliable for general issue. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Yet, Commander Yamamoto had given them a direct order. Take this captured American rifle, fire it, time it, measure it, understand it. The Imperial Japanese Navy's naval infantry had been requesting increased firepower since their bloody encounters with American forces at Guadalcanal. Marine raiders, armed with these semi-automatic weapons, had produced volumes of fire that Japanese commanders initially mistook for machine gun positions. Individual American riflemen were sustaining rates of fire that should have required 2 or even 3 Japanese soldiers with Arisaka rifles to match. The mathematics were damning. A trained Japanese soldier with a Type 38 or Type 99 Arisaka could fire perhaps 10 to 12 aimed rounds per minute under ideal conditions. The bolt had to be worked between each shot. Lift the handle, pull back, eject the spent case, push forward, chamber a new round, drive the handle down, reacquire the target, aim, fire. 4 to 6 seconds per shot, more under combat stress, more in the rain, more in the mud, more when exhausted, more when terrified. The American rifle on the workbench eliminated most of these steps. According to intelligence reports from field commanders, American soldiers were firing 20 to 30 aimed rounds per minute. Some reports claimed even higher rates. If true, if even partially true, a single American rifleman possessed the sustained firepower of 3 Japanese soldiers. Commander Yamamoto picked up the M1 Garand and worked its action. The bolt slid back with mechanical smoothness, no manual effort required beyond pulling a trigger. He had read the technical specifications captured at Bataan: gas-operated, self-loading, 8-round en-bloc clip, weight 9.5 pounds, but specifications on paper meant nothing compared to empirical testing. He turned to Lieutenant Kenji Ishida, his senior ballistics engineer. Begin the firing trials. I want precise measurements. Rate of fire, accuracy at various ranges, reliability under continuous operation. Most importantly, I want to know if our 7.7mm Arisaka cartridge will function in this American design. Lieutenant Ishida bowed slightly. Commander, with respect, we already know semi-automatic rifles are impractical. The German Gewehr 41 is notoriously unreliable. Our own Type A experimental rifles failed acceptance trials. The cost per unit would be double, perhaps triple what an Arisaka requires. Yamamoto's expression did not change. The Americans have produced over 1 million of these rifles. They are not issuing them to elite units. They are not reserving them for special forces. Every American infantryman, from private to colonel, carries this weapon. If production were truly impractical, they would not have succeeded where we failed. Now begin the test. The testing began the following morning, 6th May, on the Arsenal's rifle range overlooking Tokyo Bay. The first challenge was ammunition. The American 30-06 Springfield cartridge measured 7.62mm by 63mm. Japan's Type 99 cartridge measured 7.7 mm by 58 mm, dimensionally similar, but not identical. Lieutenant Ishida loaded a single round of Japanese ammunition into the Garand's chamber by hand, bypassing the en-bloc clip system. He aimed at a target 100 meters distant and squeezed the trigger. The rifle fired, the action cycled, the spent case ejected cleanly. A new round would have chambered if one had been available. Ishida fired a second round, then a third, then a fourth. Each time, the weapon functioned flawlessly. The gas system worked, the operating rod moved smoothly, the rotating bolt locked solidly. He lowered the rifle and turned to his colleagues, his expression transformed. It works. Our ammunition cycles the American action perfectly. Now we must test it with our 5-round stripper clips. This is where expectation and reality diverged. The M1 Garand used an 8-round en-bloc clip, a metal frame that held cartridges and fed them from within an internal magazine. The entire clip inserted into the rifle from above, and when the last round fired, the empty clip ejected automatically with a distinctive metallic ping. Japanese ammunition came in 5-round stripper clips, designed for Arisaka rifles. These clips guided cartridges into a magazine, but did not remain inside the weapon. The dimensional difference between the American 30-06 and the Japanese 7.7 mm created a fundamental incompatibility. The en-bloc clip designed for American cartridges would not reliably feed Japanese ammunition. Tests over the following 3 days revealed persistent jamming, misfeeds, and extraction failures. On May 9th, Commander Yamamoto made a decision that would define the entire project. We will not adapt our ammunition to the American system. We will adapt the American system to our ammunition. Discard the en-bloc clip mechanism entirely. Design a fixed internal magazine fed by 2 of our standard 5-round stripper clips, 10 rounds total capacity, superior to the American 8. Retain the gas operation, the rotating bolt, the self-loading action. This became the foundation of what would eventually be designated the Type 4 rifle. But before design work could begin, Yamamoto needed to demonstrate to skeptical superiors that the concept was worth pursuing. He needed numbers, hard data, undeniable proof that semi-automatic operation provided meaningful tactical advantage. On May 15, 1942, Commander Yamamoto organized a comparative fire demonstration at the arsenal. 2 teams, 3 riflemen each. Team 1 carried Type 99 Arisaka rifles, the finest bolt-action weapons Japan produced. Team 2 used 3 of the captured M1 Garands, loaded with Japanese 7.7 mm ammunition manually chambered 1 round at a time to avoid the clip incompatibility issue. The test was simple. Both teams would fire at stationary targets at 150 meters, the typical engagement range for Pacific Island combat. They would fire for exactly 1 minute. Accuracy would be measured by hits scored on man-sized silhouettes. Rate of fire would be measured by total rounds expended. The test began at 0900 hours. The Arisaka team fired with practiced efficiency. These were experienced riflemen, men who had trained on bolt-action rifles since basic training. They worked their bolts smoothly, wasting no motion. Each aimed carefully before, firing, as bolt-action doctrine demanded. Wasted ammunition was wasted ammunition. Every bullet had to count. In 60 seconds, the 3 Arisaka riflemen fired a combined total of 32 rounds, an average of 10.6 rounds per man. They scored 23 hits on the silhouettes, 71% accuracy, excellent by any standard. The Garand team fired differently. The absence of manual bolt operation changed everything. The riflemen could maintain their shooting position, never breaking their sight picture. They could fire, absorb the recoil, reacquire the target, and fire again in rapid succession. The rhythm was fundamentally different, faster, more aggressive, more sustained. In 60 seconds, the 3 Garand armed riflemen fired a combined total of 78 rounds, an average of 26 rounds per man. They scored 51 hits on the silhouettes, 65% accuracy, slightly lower than the Arisaka team, but with 2.2 times more rounds on target. Commander Yamamoto stood behind the firing line, stopwatch in hand, doing the mental mathematics. 3 Japanese riflemen with Arisaka rifles delivered 23 effective hits in 1 minute. 3 riflemen with Garands delivered 51 effective hits in 1 minute. The ratio was stark, 2.2 to 1, not a marginal improvement, a transformation of infantry combat capability. He turned to the naval staff officers observing the demonstration. "Gentlemen, you have just witnessed the future of infantry warfare. A single soldier with a semi-automatic rifle delivers more than twice the combat effectiveness of a soldier with a bolt-action weapon. The Americans did not develop this technology because they are wasteful or undisciplined. They developed it because it works." One of the staff officers, Captain Hiroshi Nakamura from the Navy General Staff, stepped forward. "Commander, the demonstration is impressive, but you are comparing a captured foreign weapon, manually, loaded 1 round at a time, against our standard service rifle. You have not demonstrated that we can manufacture such a weapon reliably, in quantity, at acceptable cost, using our own ammunition feeding system." Yamamoto expected this objection. In early 1944, 10 rifles were modified to 7.7 by 58 mm for testing. Functional testing and evaluation proved to be highly satisfactory. "Sir, you have identified exactly what we intend to prove. With your authorization, Yokosuka Arsenal will reverse engineer the M1 Garand, adapt it to our 7.7 mm cartridge, redesign the magazine system for our 5-round stripper clips, and produce functional prototypes within 18 months. We will demonstrate that Japanese engineering can not only copy American designs, but improve them." The authorization came through on May 24, 1942, but it came with strict limitations. The project would be classified as a spare-time activity, worked on only when the arsenal's primary production commitments allowed. The machine gun plant on the 3rd floor would handle development between contracts for 25 mm anti-aircraft cannons, Lewis machine guns, and Vickers machine guns. No dedicated staff. No additional funding. No interference with existing war production. Commander Yamamoto accepted these constraints without complaint. He understood Japan's strategic situation in mid-1942. Every factory, every worker, every yen was stretched to maximum capacity. The early victories at Pearl Harbor, Wake Island, Guam, and the Philippines had given way to grinding attrition in the South Pacific. American industrial capacity was ramping up. Japanese resources were finite. A semi-automatic rifle project could not take priority over aircraft, ships, or artillery. Yet Yamamoto also understood something his superiors did not fully grasp. The firepower disadvantage Japanese infantry faced against American troops was not tactical. It was existential. Every engagement report from Guadalcanal, every after-action review from Tulagi, every casualty list from Bougainville told the same story. Japanese soldiers with bolt-action rifles were being outgunned by Americans with semi-automatic weapons. Training could not close this gap. Courage could not close this gap. Only technology could close this gap. The work began in June 1942. Lieutenant Ishida led a team of 6 engineers in meticulous disassembly and measurement of the captured M1 Garands. Every component was documented, dimensions recorded, materials analyzed, operating principles studied. The Garand's genius lay in its gas operation system. When fired, a portion of the propellant gases from the burning gunpowder was tapped off through a port in the barrel. These gases pushed against a piston connected to an operating rod. The operating rod drove backward, rotating and unlocking the bolt. The bolt extracted the spent cartridge case, cocked the hammer, compressed the operating spring, and allowed a new round to chamber from the magazine. The entire cycle took 1/5 of a second. Ishida's team created detailed technical drawings of every part: the receiver, the barrel, the gas cylinder, the operating rod, the bolt assembly, the trigger mechanism, the hammer spring, 73 separate components, each requiring precise manufacturing tolerances. By September 1942, they had complete blueprints. The challenge shifted from understanding the design to adapting it. The most significant modification was the magazine system. The American en-bloc clip entered the magazine from above and remained inside until the last round fired. This required a specific internal geometry that would not work with Japanese 5-round stripper clips. Ishida proposed a solution: replace the en-bloc clip system with a fixed internal magazine similar to the Arisaka, but with double the capacity, 10 rounds total, loaded by inserting 2 5-round stripper clips in succession from the top of the receiver. The modification required redesigning the magazine well, the follower spring tension, and the clip guide rails, but it would make the rifle compatible with existing Japanese ammunition logistics. Every soldier in the Imperial Army already carried 5-round stripper clips for their Arisaka rifles. Adopting this system meant no additional supply chain modifications. Other changes followed. The rear sight was replaced with a traditional Japanese tangent sight, graduated from 100 meters to 1200 meters. The front sight was modified to accept the Type 30 bayonet. The sling swivels were repositioned to match Japanese carrying preferences. The stock profile was adjusted slightly to accommodate the average Japanese soldier's shorter stature and arm length. By December 1942, the first prototype was complete. It was a hybrid, recognizably descended from the M1 Garand, but distinctly Japanese in its adaptations. Yamamoto held the weapon, worked the action, checked the sight picture. It felt right. It felt possible. The first live fire test took place on December 18, 1942. The prototype was loaded with 10 rounds of Type 99 7.7mm ammunition via 2 5-round stripper clips. Lieutenant Ishida chambered the first round by working the bolt manually. He aimed at a target 50 meters distant. He fired. The rifle cycled smoothly. The spent case ejected. A new round chambered. He fired again, and again, and again. All 10 rounds fired without malfunction. Yamamoto allowed himself a rare smile. Now, test it under stress. Fire 100 rounds as rapidly as possible. We need to know if the action can handle sustained operation without failure. Over the next hour, the prototype fired 240 rounds with only 3 failures. 2 failures were due to improperly seated, stripper clips, operator error, rather than mechanical failure. 1 failure was a broken extractor claw, a weak point that required metallurgical improvement. 98.7% reliability. Better than many bolt-action rifles. Better than the German Gewehr 41. Better than earlier Japanese semi-automatic attempts. Yamamoto submitted his interim report to the Navy General Staff on January 5, 1943. The report concluded with a straightforward assessment. Semi-automatic rifle technology is not theoretical, it is practical. The Americans have proven this with over 1 million M1 Garands in service. We have successfully adapted the American design to Japanese ammunition. We have achieved reliability rates exceeding 98%. We require authorization to proceed to limited production for field testing. The response took 4 months. On May 2, 1943, authorization arrived. Proceed to manufacture 250 rifles for evaluation. Designation: Type 4 semi-automatic rifle. Production target: January 1945. But the authorization came with a devastating caveat. Yokosuka Arsenal cannot support production. Contract the work to a private manufacturer. Find a company with available capacity. Yamamoto understood immediately what this meant. No government arsenal had spare capacity in 1943. Private manufacturers were even more strained. Finding a company willing to take on a complex, untested weapon system during wartime would be nearly impossible. He spent 2 months searching. Every major arms manufacturer declined. Mitsubishi was fully committed to aircraft production. Tokyo Arsenal was producing Type 92 machine guns at maximum capacity. Nagoya Arsenal had no experience with gas-operated firearms. Finally, in July 1943, Washino Kikai Company in Aichi Prefecture agreed to attempt production. Washino was a small concern, primarily manufacturing automotive components and agricultural machinery. They had no firearms experience, they had no specialized gun-making equipment, but they had available floor space, and they were willing to try. Yamamoto had no choice. He accepted. Production planning began in August 1943, but immediately encountered problems. Washino Kikai did not own the machine tools necessary for rifle parts manufacturing. They could not produce barrels. They could not machine bolts to the required tolerances. They could not heat-treat components properly. The solution was a compromise. Yokosuka Arsenal would manufacture the complex components, the barrels, bolts, operating rods, and receivers. Washino would assemble the rifles from Yokosuka-supplied parts. This was not mass production, this was hand assembly, but it was the only option available. By January 1944, Washino had assembled the first 20 rifles. These were hand-fitted, carefully inspected, virtually custom-made. Yamamoto took possession of the rifles and organized comprehensive field trials at the Naval Infantry Training Facility in Yokosuka. The trials lasted 3 weeks, January 15 through February 5, 1944. Naval infantry recruits, men who had never fired a semi-automatic rifle, were trained on the Type 4. The results exceeded expectations. Average time to basic proficiency, 4 days. Average time to the same proficiency with an Arisaka, 7 days. The semi-automatic action was easier to learn, easier to master. Recruits did not have to develop the muscle memory for smooth bolt operation. They simply aimed and pulled the trigger repeatedly. After 2 weeks of training, a comparison exercise was conducted. 1 platoon armed with Type 99 Arisakas. 1 platoon armed with Type 4 semi-automatics. Both platoons conducted assault exercises against simulated defensive positions. The Type 4 platoon completed the exercises with 32%, fewer casualties in simulated combat. They suppressed enemy positions more effectively. They maintained fire during movement more consistently. They overwhelmed defensive positions through volume of fire rather than tactical maneuver. The tactical implications were clear. Give Japanese infantry semi-automatic rifles, and they could compete with American firepower. Deny them semi-automatic rifles, and they would continue to fight at a disadvantage that training and courage could not overcome. Commander Yamamoto submitted his final report to the Navy General Staff on February 12, 1944. The report was unambiguous. The Type 4 rifle is operationally superior to the Arisaka in every measurable category. Rate of fire, 2.4 times higher. Training time, 40% shorter. Simulated combat effectiveness, 32% improved. I recommend immediate authorization for mass production. Minimum initial order, 50,000 rifles for naval infantry and naval paratroops. This will give our forces parity with American infantry firepower. The response came on March 1, 1944. Authorization granted for continued production. Target quantity, 250 rifles. No authorization for mass production at this time. Yamamoto read the authorization twice, hoping he had misunderstood. He had not. 250 rifles. Not 50,000. Not even 5,000. 250. Less than enough to equip a single regiment. In a navy that fielded hundreds of thousands of infantry across the Pacific, the reason was brutally simple. Japan's industrial capacity in early 1944 was collapsing. American submarines were sinking cargo ships faster than Japan could replace them. Raw materials were scarce. Skilled workers were being drafted. Factories were being bombed. Producing a complex semi-automatic rifle, even one proven effective, was a luxury Japan could no longer afford. The Arisaka bolt-action rifle cost 70 yen to manufacture. The Type 4 cost an estimated 180 yen. 2.5 times more expensive. Japan needed rifles immediately, in massive quantities, at minimum cost. The Type 4 was none of these things. Washi no Kikai continued assembly through 1944, working with the parts supplied by Yokosuka Arsenal. By August 1944, approximately 100 rifles had been completed. By December 1944, 125. Production was glacial. Quality control was inconsistent. Some rifles functioned flawlessly, others jammed repeatedly. The project was dying. On March 10, 1945, American B-29 bombers struck Tokyo in the most devastating air raid of the war. The firebombing killed over 100,000 civilians and destroyed 16 square miles of the city. Yokosuka Arsenal, located south of Tokyo, on Tokyo Bay, was not directly hit, but the message was clear. The war was coming to Japan's home islands. American invasion was inevitable. Commander Yamamoto stood in the arsenal's courtyard on the morning of March 11th, watching smoke rise from Tokyo's ruins. Around him, workers salvaged what they could from damaged buildings. He thought about the Type 4 rifles locked in storage, proven technology, superior design, unusable, too late. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. On April 1, 1945, American forces landed on Okinawa. The battle would last 82 days and cost over 100,000 Japanese military casualties. Japanese defenders fought with Arisaka rifles. American attackers fought with M1 Garands. The firepower differential was exactly what Commander Yamamoto had tried to address 3 years earlier. By July 1945, the Type 4 rifle project was effectively abandoned. Washi no Kikai had assembled approximately 125 rifles from the 250-part sets. The remaining parts sat in crates, unassembled. No one had time to finish them. No one had resources to finish them. On August 6, 1945, an atomic bomb destroyed Hiroshima. On August 9th, a second atomic bomb destroyed Nagasaki. On August 15th, Emperor Hirohito announced Japan's unconditional surrender over the radio. The war was over. On September 2, 1945, American occupation forces arrived at Yokosuka Naval Arsenal. They found warehouses full of captured equipment, experimental weapons, and incomplete production runs. Among the items catalogued were approximately 125 Type 4 semi-automatic rifles, various stages of completion, and parts for 125 more rifles. American ordnance officers examined the Type 4 with professional interest. A.U. Army Technical Intelligence Report dated November 1945 stated, "The Japanese Type 4 rifle is a close copy of the US. M1 Garand, modified for Japanese 7.7mm ammunition and stripper clip loading. Build quality varies considerably. Some examples show excellent machining and finish. Others show evidence of hasty assembly and poor quality control. None of these rifles are known to have seen combat use. The project appears to have been a late-war attempt to match American infantry firepower, abandoned due to resource constraints." 20 Type 4 rifles were selected for detailed study and shipment to the United States. The remainder were stored, then eventually scrapped or dispersed. A few found their way into private collections. Today, Type 4 rifles are among the rarest World War II firearms. Fewer than 50 examples are known to exist. In 1948, Commander Takeo Yamamoto, retired from service and working as a consulting engineer in post-war Japan, gave a lecture at Tokyo University on military firearms development. A student asked him about the Type 4 project. "Commander, if the Type 4 had been produced in large numbers, could Japan have matched American infantry firepower?" Yamamoto considered the question carefully. He was no longer bound by military protocol, no longer required to maintain operational security. He could speak honestly. The Type 4 was technically sound. It worked. It was reliable. It improved combat effectiveness. but producing it in meaningful numbers would have required resources Japan did not possess in 1944. Steel alloys, machine tools, skilled labor, manufacturing capacity. Most importantly, time. The Americans began developing the M1 Garand in 1923. We began developing our copy in 1942. We were 19 years behind. 19 years is not a gap you close during wartime. The student pressed further. But if Japan had started development earlier, say in the 1930s, could we have fielded a semi-automatic rifle before the war? Yamamoto's expression was somber. Yes. If we had recognized the importance of infantry firepower in the 1930s, if we had invested in semi-automatic rifle development when we had resources, if we had not dismissed such weapons as impractical luxuries, yes, we could have. But we did not. We believed our bolt-action rifles were sufficient. We believed American soldiers were inferior marksmen who compensated with volume of fire. We believed Japanese discipline and training would overcome any technological disadvantage. We were wrong about all of it. The lecture concluded, but Yamamoto's words captured something profound about the Type 4 project and its failure. It was not a failure of engineering. It was not a failure of design. It was a failure of strategic foresight. Japan had the technical capability to develop semi-automatic rifles. They had tested such weapons in the 1930s. They had examined foreign designs. They had the metallurgical knowledge, the manufacturing experience, the engineering talent. What they lacked was recognition that infantry firepower was about to become decisive in modern warfare. The Type 4 rifle represented Japan's attempt to catch up, to match American infantry capabilities after the disadvantage became undeniable. But by the time Japanese engineers at Yokosuka proved the concept worked, Japan no longer had the industrial capacity to produce it. The Americans, by contrast, had started the M1 Garand project in peacetime, invested in development through the 1920s and 30s, solved manufacturing problems gradually, and scaled up production before war began. By 1941, when Japan attacked Pearl Harbor, the United States had already produced hundreds of thousands of M1 Garands. By 1945, the number exceeded 5.4 million. Japan managed to produce 125 Type 4 rifles. The ratio speaks for itself. The story of the Type 4 is ultimately a story about industrial capacity and timing. The Japanese engineers at Yokosuka proved that copying the M1 Garand was technically feasible. The rifle worked. It was reliable. It improved combat effectiveness measurably. But feasibility and practicality are different things. Japan, in 1944, could not mass-produce complex semi-automatic rifles while simultaneously producing aircraft, ships, artillery, ammunition, and everything else required to wage total war across the Pacific. The Americans could, because American industrial capacity in World War II was effectively unlimited. U.S. factories produced 2.6 million trucks, while Japan produced 160,000. US factories produced 300,000 aircraft, while Japan produced 70,000. U.S. factories produced 5.4 million M1 Garands, while Japan produced 125 Type 4 rifles. These are not differences in engineering quality or worker discipline. These are differences in industrial scale. The Japanese soldier facing an American infantryman in 1944 was not fighting against superior training or better tactics. He was fighting against an entire nation's productive capacity, manifested in the rifle his opponent carried. Every engagement in the Pacific illustrated this reality. At Tarawa in November 1943, Japanese defenders with Arisaka rifles faced Marine assault forces equipped with M1 Garands. The Marines could sustain fire while advancing across exposed beaches. Japanese defenders had to expose themselves to work their bolts between shots. At Saipan in June 1944, the same pattern repeated. At Peleliu in September 1944, again. At Iwo Jima in February 1945, the disparity became even more pronounced. American commanders understood that their infantry possessed a fundamental firepower advantage. They structured tactics around it: aggressive movement under covering fire, fire and maneuver, overwhelming suppression of defensive positions. These tactics worked because every rifleman could sustain high rates of accurate fire without interruption. Japanese commanders, by contrast, had to compensate for firepower disadvantage through other means. Night attacks that negated American fire superiority, infiltration tactics that avoided direct engagement, fortified defensive positions that maximized the effectiveness of limited firepower. These adaptations worked to some degree, but they were adaptations to weakness, not expressions of strength. The Type 4 rifle project represented an attempt to eliminate that weakness. If Japanese infantry could match American firepower, they could adopt American tactics. They could fight on equal terms. They could stop losing firefights simply because their rifles required manual operation between shots. But the attempt came too late, and, with insufficient resources, by the time Commander Yamamoto proved the Type 4 concept worked, Japan was already losing the war. Industrial collapse made mass production impossible. Strategic bombing destroyed what manufacturing capacity remained. Submarine warfare cut off raw material imports. The home islands were preparing for invasion. In this context, producing semi-automatic rifles was no longer a priority. Japan needed basic weapons immediately. Simple, cheap, producible by unskilled workers in dispersed workshops. The late-war substitute standard Arisaka rifles reflected this reality. No finish, crude machining, simplified sights. Some were dangerous to fire, but they could be produced quickly and cheaply when steel, skilled labor, and machine tools were all in short supply. The Type 4 required precision manufacturing, heat-treated components, and careful assembly. Everything Japan no longer possessed. The contrast with American production is instructive. In January 1944, Springfield Armory alone produced 28,000 M1 Garands. Winchester Repeating Arms produced another 10,000. Total American production that month exceeded 38,000 rifles. In the same month, Japan's entire Type 4 program managed to assemble perhaps 6 rifles. Not 6,000. 6. The disparity was not temporary. It was structural. American industry in World War II operated at such enormous scale that quality and complexity were not obstacles. The United States could afford to equip every infantryman with a 9.5-pound semi-automatic rifle because American factories could produce them by the millions. Japan could not afford to equip even elite units with semi-automatic rifles because Japanese factories could barely produce rifles at all by 1944. This reality extended beyond small arms. American shipyards produced 151 aircraft carriers during World War II, counting fleet, light, and escort carriers. Japan produced 25. American aircraft factories produced 97,000 fighters. Japan produced 30,000. American tank factories produced 88,000 tanks. Japan produced 6,000. The pattern repeated across every category of military production. American material superiority was comprehensive, overwhelming, and decisive. The M1 Garand was simply one manifestation of this broader industrial dominance, but it was a particularly visible manifestation, present in every infantry engagement, every patrol action, every small unit firefight. The Japanese soldier facing an American counterpart could see the difference directly. He could hear it in the continuous crack of semi-automatic fire. He could feel it in the volume of incoming rounds. He could measure it in casualties suffered. Intelligence reports from Japanese units engaged with American forces repeatedly mentioned the firepower disadvantage. A report from the 6th Army defending Luzon in January 1945 stated, "Enemy infantry possesses significant advantage in rate of fire. Individual riflemen maintain continuous fire while advancing. Our soldiers must expose themselves to work rifle bolts between shots. This results in higher casualties during movement and assault. recommend increased allocation of automatic weapons to compensate. But there were no additional automatic weapons to allocate. Japanese industry was producing Type 96 and Type 99 light machine guns as fast as possible, but not fast enough to change the tactical balance. Machine guns required three-man crews, specialized ammunition, and were vulnerable to suppressive fire. Semi-automatic rifles distributed firepower to every individual soldier. You could not suppress 8 riflemen the way you could suppress 1 machine gun crew. Another report, this one from a special naval landing force unit on Okinawa in April 1945, was more direct. The American semi-automatic rifle gives them an advantage we cannot overcome with current weapons. We attempt to compensate through superior positioning and night operations, but during daylight engagements, their volume of fire consistently overwhelms our positions. Without equivalent weapons, we are fighting at permanent disadvantage. These were not excuses. These were factual assessments from experienced officers who understood what they were facing. The solution was obvious. Japan needed semi-automatic rifles. The Type 4 proved it was possible. But knowing something is possible and actually doing it are different challenges entirely. By mid-1945, the Type 4 project existed primarily as stored parts at Yokosuka Arsenal and a handful of assembled rifles in various states of completion. There was no production schedule, no delivery timeline, no units waiting to receive the weapons. The project had become irrelevant to the immediate struggle for survival. When American forces occupied Yokosuka on September 2, 1945, they found the Type 4 rifles in storage. U.S. Army Ordnance officers photographed them, measured them, and test-fired several examples. Their assessments were professional and objective. The design was sound. The modifications to accommodate Japanese ammunition were well executed. The manufacturing quality varied but was generally acceptable. One ordnance report noted, "The Japanese Type 4 demonstrates that enemy engineers fully understood the advantages of semi-automatic operation and were capable of reverse engineering complex weapons systems." The limited production numbers reflect Japan's industrial limitations rather than any technical shortcomings in the design. This assessment was accurate. Japanese engineers had solved the technical problems. They had created a functional semi-automatic rifle adapted to Japanese requirements. What they could not solve was the strategic problem of producing such rifles in meaningful quantities during the final 2 years of a losing war. 20 Type 4 rifles were shipped to Aberdeen Proving Ground in Maryland for detailed technical evaluation. American engineers dismantled them completely, photographed every component, created detailed technical drawings, and tested them extensively. The conclusion was straightforward. The Type 4 was essentially a Japanese M1 Garand with modified magazine system. It worked as intended. In different circumstances, with earlier development and adequate production capacity, it could have equipped Japanese forces effectively. But circumstances were not different. Development was not earlier. Production capacity was not adequate. The Type 4 remained a might have been, an example of what Japan could have achieved with more time and more resources. The rifles tested at Aberdeen were eventually deposited in U.S. military museums and storage facilities. A few were later released to civilian collectors. Most of the Type 4s left at Yokosuka were disposed of through various means. Some were destroyed, some were sold as scrap. A few were retained by Japanese police forces during the occupation period, though records of this are fragmentary. Today, the Type 4 rifle is extraordinarily rare. Perhaps 50 examples exist worldwide. The National Firearms Museum in Fairfax, Virginia, has one on display. The Royal Armouries in Leeds, United Kingdom, has another. Private collectors own a handful more, typically paying tens of thousands of dollars when examples appear at auction. The rarity reflects the limited production. Only about 125 rifles were ever completed. Of those, 20 went to the United States for testing. Perhaps another 30 survived the immediate post-war period in Japan. Attrition over 75 years reduced that number further. Each surviving Type 4 represents a tangible connection to a failed project, a road not taken, a solution that arrived too late. For military historians and firearms collectors, the Type 4 is significant precisely because of its failure. It demonstrates that Japan recognized the firepower disadvantage they faced. They understood the problem. They developed a technical solution. They proved it worked. What they could not do was implement the solution at scale during wartime. The story of the Type 4 is therefore not primarily about engineering. It is about industrial capacity, strategic planning, and the consequences of starting too late. The United States developed the M1 Garand during peacetime, over a period of more than 15 years. Japan attempted to develop an equivalent during wartime, under pressure, with collapsing industrial capacity. The outcomes were predictable. In 1954, 9 years after the war ended, the newly formed Japan Self-Defense Forces began receiving weapons from the United States as part of post-occupation military assistance. Among the weapons provided were M1 Garand rifles, thousands of them. The rifles that Japan could not produce during the war, that Commander Yamamoto had tried to copy, that the Type 4 project attempted to replicate, were now being issued to Japanese forces by their former enemies. The irony was not lost on Japanese military personnel. Officers who had fought with Arisaka rifles against American Garands were now training recruits on American Garands. Soldiers who had witnessed the firepower disadvantage firsthand were now benefiting from American industrial surplus. The circle was complete, though not in any way Japan had anticipated. The M1 Garand served with the Japan Self-Defense Forces into the 1960s, eventually replaced by more modern weapons. During that service, Japanese soldiers learned what American soldiers had known since 1943. Semi-automatic operation fundamentally changes infantry combat. The ability to fire rapidly without manual bolt operation increases effectiveness, dramatically. Training is simplified. Fire and maneuver tactics become more practical. Suppressive fire can be maintained by individual soldiers rather than requiring crew-served weapons. Everything Commander Yamamoto had documented in his 1944 reports proved true in Japanese service as well. But by the time Japan received these rifles, the context was entirely different. The self-defense forces were not fighting a war. They were training for potential defense of the home islands during the Cold War. The Garands were sufficient for this purpose, proven reliable, and available in large quantities at minimal cost. The Type 4, in contrast, remained a historical curiosity. A few examples in museums, a few more in private collections. Most people, even in Japan, have never heard of it. The rifle represents a footnote in World War II firearms development, interesting primarily to specialists. Yet the story behind the Type 4 reveals something important about the Pacific War. It reveals that Japanese military leadership understood the technological disadvantages they faced. They were not blind to American firepower superiority. They attempted to address it through weapons development. They made rational decisions based on available information. But they were constrained by circumstances beyond their control: industrial capacity, raw materials, time, strategic position. These constraints made semi-automatic rifle production impractical, regardless of how well the Type 4 performed in testing. The comparison with Germany is illuminating. Germany also attempted to develop semi-automatic rifles during World War II. The Gewehr 41 appeared in 1941 but proved unreliable. The improved Gewehr 43 entered production in 1943 and was issued in limited numbers. Germany produced approximately 400,000 Gewehr 43s during the war. This was far more than Japan's 125 Type 4s, but still a tiny fraction of the 5.4 million M1 Garands the United States produced. Germany had greater industrial capacity than Japan, better access to raw materials, less vulnerability to strategic bombing in the early war years, and more advanced manufacturing infrastructure. Yet even Germany could not match American semi-automatic rifle production. The United States produced more M1 Garands than Germany produced all rifles of all types in the same period. This was not a marginal advantage. This was industrial dominance of a scale that made competitive production impossible for any other nation. The Soviet Union did produce substantial numbers of semi-automatic rifles, primarily the Tokarev SVT-38 and SVT-40. Approximately 1.6 million were manufactured, but Soviet production emphasized simplicity and acceptable reliability rather than the precision and refinement of the M1 Garand. The SVT rifles worked adequately, but were withdrawn from frontline service by 1945 in favor of submachine guns for most infantry. Only the United States made semi-automatic rifles standard issue for all infantry throughout the war and beyond. This reflected not just industrial capacity, but also logistics capability. Semi-automatic rifles consume more ammunition than bolt-action rifles. American soldiers could fire 20 to 30 rounds per minute, meaning they needed roughly 3 times as much ammunition as soldiers with bolt-action rifles. The United States could supply this ammunition. American logistics was so efficient that ammunition shortages were rare even during intense combat. Japan could not have supplied such volumes of ammunition even if the Type 4 had entered mass production. Japanese logistics struggled to deliver basic supplies to forward units. Food. Medicine. Replacement parts. Ammunition for existing weapons was often in short supply. Tripling ammunition consumption for semi-automatic rifles would have overwhelmed an already failing system. This was another constraint on Type 4 production that had nothing to do with the rifle itself. You cannot issue weapons you cannot supply with ammunition. You cannot supply ammunition you cannot manufacture and transport. Japan could do neither by 1944. The Type 4 project died not from any single cause, but from accumulated impossibilities. Commander Yamamoto's engineering team had done everything right. They had analyzed the M1 Garand correctly. They had adapted it appropriately for Japanese requirements. They had proven it worked reliably. They had demonstrated improved combat effectiveness. None of this mattered because the strategic situation made implementation impossible. In his later years, Yamamoto occasionally spoke about the project with colleagues and students. He never expressed bitterness about the outcome. He understood that the Type 4's failure was not a personal failure but a systemic one. Japan in 1944 faced constraints that no amount of engineering competence could overcome. What Yamamoto did express was regret about timing. If Japan had started semi-automatic rifle development in the early 1930s, when resources were available and peace still prevailed, the outcome might have been different. If Japanese military leadership had recognized the importance of infantry firepower before the war began, they might have fielded effective semi-automatic rifles before resource constraints became binding. If Japan had not dismissed American military technology as wasteful and undisciplined, they might have learned from the M1 Garand program earlier. These were all strategic decisions made years before Yamamoto began his work. He inherited the consequences. In 1968, 23 years after the war ended, a firearms historian from the United States visited Yamamoto at his home in Tokyo. The historian was researching Japanese World War II weapons and development and wanted to learn about the Type 4 directly from someone involved in the project. Yamamoto, now 74 years old, received the visitor courteously. They spoke for several hours. Near the end of the conversation, the historian asked a question Yamamoto had been asked many times before. "Commander, if the Type 4 had been produced in large numbers and issued to Japanese forces in 1944, would it have changed the outcome of the war?" Yamamoto's answer was immediate and definitive. No, the Type 4 was a good rifle. It worked well. It would have improved the combat effectiveness of units that received it. But it would not have changed the war's outcome. By 1944, Japan was not losing because of inadequate rifles. Japan was losing because of inadequate everything: ships, aircraft, fuel, trained pilots, industrial capacity, access to resources, strategic position. The United States had overwhelming advantages in all these areas. Better rifles for Japanese infantry would have made individual engagements more competitive. They would have reduced casualties in firefights. They might have extended some defensive battles by days or weeks, but they would not have prevented American forces from advancing island by island toward Japan. They would not have stopped the submarine campaign that destroyed Japanese merchant shipping. They would not have prevented the strategic bombing that devastated Japanese cities. They would not have negated American industrial capacity that produced more of everything faster than Japan could respond. The war was decided by factors beyond infantry small arms. The Type 4 could only address one narrow tactical problem in a war defined by strategic imbalances. The historian pressed further. But surely the rifle would have saved Japanese lives, even if it did not change the ultimate outcome? Yamamoto's expression softened. Yes, that is true. The Type 4 would have saved lives. Japanese soldiers, with semi-automatic rifles, would have been more effective in combat. They would have inflicted more casualties on American forces. They would have survived longer themselves. Many men who died because they could not fire fast enough might have lived if they had carried Type 4s instead of Arisakas. From that perspective, the failure to produce the rifle in quantity was a tragedy. We knew it was better. We proved it worked. We could not make enough of them when it mattered. The conversation ended shortly after. The historian thanked Yamamoto for his time and insights. Yamamoto walked him to the door, then paused. You should understand something. The M1 Garand was not just a better rifle. It was a symbol of American industrial power. Every Japanese soldier who faced it understood that he was not just fighting American soldiers. He was fighting American factories, American steel mills, American tool manufacturers. The rifle in his opponent's hands represented a nation that could produce complex weapons in millions, while Japan struggled to produce simple weapons in thousands. That was the real lesson of the Type 4 project. We could design the rifle. We could not produce it. That difference decided everything. These were Yamamoto's last recorded comments about the Type 4. He died in 1973 at age 79, having lived long enough to see Japan transform from defeated nation to economic powerhouse. The post-war Japanese industrial miracle would have seemed impossible in 1945, yet by the 1970s, Japan was producing automobiles, electronics, and machinery that competed globally. The industrial capacity that could not produce semi-automatic rifles in wartime became one of the world's most productive economies in peacetime. The Type 4 rifle project remains a small chapter in the larger story of World War II. It produced no significant historical consequences. No battles were won or lost because of it. No tactical innovations resulted from it. The rifle appeared too late and in too few numbers to matter militarily. Yet for those interested in the detailed reality of the Pacific War, the Type 4 tells an important story. It demonstrates that Japan recognized American technological advantages and attempted to match them. It shows that Japanese engineers possessed the technical capability to reverse engineer complex weapons systems. It proves that the problem was not knowledge or skill, but resources and timing. Most importantly, it illustrates how industrial capacity shapes military outcomes more than individual weapons design. The M1 Garand was an excellent rifle, but its real power came from being produced by the millions and supplied with limitless ammunition. The Type 4 was also an excellent rifle, but its potential was negated by being produced by the dozens with no prospect for mass manufacture. In the end, the story of Japanese generals testing a captured Garand comes down to a simple truth. They tested it. They understood immediately what it represented. They recognized the firepower advantage it provided. They successfully copied its essential features. They proved their copy worked reliably. And then they discovered that understanding a problem and solving a problem are entirely different challenges. The Type 4 could fire 8 rounds in seconds, just like the M1 Garand it copied. It proved Japanese engineering could match American design, but Japan could not match American industry, and in industrial warfare, industry decides outcomes more than engineering ever can. The captured M1 Garands tested at Yokosuka Naval Arsenal in 1942 revealed a truth Japanese generals already suspected but hoped to deny. They were facing an enemy who could produce superior weapons in unlimited quantities. The Type 4 represented an attempt to narrow that gap. It succeeded technically. It failed strategically. And in war, strategic failure is the only kind that matters. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.